So here we have the final answer. I think it's about 0.04, something like that. Okay, so here we have 4 variants. Then after that, you can find what is your standard deviation, which is square root of the variance here. Okay, so 0.04. Okay, so I leave it to you to try to get the final answer. Okay, so you can take screenshot of this if you have done if you have not copied this. All right, take a screenshot. Make sure you solve this later on once you are back at your notes. Okay, so this is question 1. Very simple. So let's go to question 2. Question 3. I think question 2 I leave it to you to do. Right, so let's go to question 3. When you give a casino $5 for a bet on the pass line in a casino game of dice. So this is a dice game. So there is a probability that 251 over 495 probability that you will lose, and there is 244 over 495 probability that you will make a net gain. So if you win, casino gives you $5 and you get to keep your $5 back. So the net gain is $5. So what is your expected value? In the long run, how much do you lose for each bet? Okay, so this kind of question is lengthy. So you need to break down what is this talking about. We have a casino with given to us as a $5 bet. So from this $5 bet, if we win, win means that you make a net gain. So the probability is about 244 over 495. So which means that you have a plus $5. So you are winning $5. Okay. Now we are looking at when you lose. So the probability that when you lose is given to us as 251 over 495. Okay. So for this case, we are looking at what kind of distribution? As I mentioned before, we have win, lose. What do you think? What kind of distribution? Is it a standard deviation? Is it binomial? Is it Poisson? Okay, good. So some of you already answered. This is a binomial. All right. So this is a binomial. We have a win and we have losing. So there is 2 possibilities. Okay. But look again at the question itself. So let's say we look at this is a binomial. Let me put that this is losing $5. So the question asks you, what is your expected value? Okay, so expected value, we're not really talking about binomial. We are only on the case of expected value for discrete probability distribution. So expected value is the same as equals to mu. Okay, for discrete probability distribution, which is the summation of x times dx. Okay, even though this sounds like a binomial distribution, all right, but the question itself only talks about looking at how to calculate the expected value, which is related to mu. So we are looking at what is x, and also we need to know how to get the px. Okay, so we have to decide what is our x. So our x must be related as about how much you will gain or how much you will lose. So for this case, our x, positive 5 will be when we win, and then negative 5 is when we lose. So therefore, our x values will be negative 5 and also 5. I'm omitting the positive value. So these are the two x values that you will see for your probability. Then the probability of x, okay, so when probability of x is equals to negative 5, the probability will be 251 over 495. And then when x is equals to 5, the probability will be 244 over 495. Okay, so these are the only two. Actually, you can make this as a table, right? We have x, px, negative 5 and 5, 251 over 495, and etc. So from there, we can actually calculate what is our expected value. We've already identified our x. So we have a negative 5 times with 251 over 495 plus with 5 times with 244 over 495. Okay, so I leave it to you to calculate what would be this expected value. Alright, so here in the long run, because expected value is actually looking at the average, okay, because this is looking at mu, so therefore this is actually trying to solve for this case what would be the average outcome, okay, in the long run. So how much do you lose for each dollar bet? All right, so try to calculate this, see what you get. Okay, take a screenshot. I don't know whether you get a positive or negative. Okay, so from there, if you look at, you are getting negative. Okay, if you get negative value, so this means that you are losing some money. If you get some positive value, so you are actually gaining. Okay, so for this case, we want to look at what will be the value that you get. Okay, over here, is it a negative or is it positive? All right, so once you have this value, there's one part that you have to answer. How much do you lose for each dollar bet? So for each dollar bet, how much do you lose? So from this answer, you'll get some value. For example, maybe your answer is 10. So for this case, you are betting $5. So you want to see how much do you lose for each dollar bet that you've already, for the $5 bet that you've already used in this game. So from there, you have to divide it by 5, see how much is the final answer. Okay, maybe it is in terms of 0. Maybe 2. What do you get? Negative 7 over 99. Where do you get the 7? Where do you get the 99? Yeah, it's supposed to be 7 cents. Correct. It's 7 cents. No, it's not 0.07 cents. It's 7 cents. I think you should get about negative 35 over 495, if I'm not mistaken. Somewhere here. Do you get this value? Make sure you multiply the correct number. This should be the final answer. Convert this. You get 7 cents, which is $0.07. So you will get 7 cents. Okay. All right. So I'm going to move along. Take screenshot of this and then you can try this on your own. Okay. Right, so, oh, it's, okay, all right. So now we go to the next question. All right, so I think this question is kind of long. I'm gonna skip this one and I'll redo this and post to you the final answer on the Telegram channel. Because why? This is talking about the number of girls in a family of 4 children. So it's best if we list out the possibilities and then try to solve this problem. So I'm gonna skip this part. Let's do this question. So we have an author that purchased a slot machine that is configured so that there is a 1 over 2000 probability of winning any jackpot on any individual trial. So although no one would seriously consider tricking the author, suppose that a guest claims that he played the slot machine 5 times and hit the jackpot twice. So find the probability of exactly 2 jackpots in 5 trials. Okay, I want to ask you, what distribution is this? Is it the discrete probability standard one, or is it binomial, or is it Poisson? Okay, so you say binomial, all right. Okay, so that's good. Right, so again, this is one possible keyword for this. Okay, so we have this keyword. Okay, winning. So we have a winning probability, which means that, okay, so this may look like P is equals to 1 over 2000. Okay. Then, although no one seriously considered tracking the author, suppose that a guest claims that he played the slot machine 5 times, which means that this is the number of trials. Okay. So the trials here lead to n. So n is equal to 5 and hit the jackpot twice. So find the probability of exactly 2 jackpots in 5 trials. So you are looking at what is the probability of x equals to 2. Okay, so binomial distribution, we are looking at px equals to r again. It is talking about NCR, p to the power of r, q to the power of n minus r. So NCR, very easy for you to find that in your calculator. Okay, so n here will be 5. So we are looking at px equals to 2. So here will be 5c2. P is 1 over 2000 to the power of r. What is r? So this is 2. Then we have q will be 1 minus 1 over 2000. So that is about 1999 over 2000 to the power of 5 minus 2. So to the power of 3. Okay. So punch this number in your calculator. You should get a very small number. I think about 0.00, how many zeros is this? About 5. Okay, so you get something like that. Okay, px equals to 2 for this question. Then we find the probability of at least. Okay, so when we use the concept of at least, you have to figure out, is it more than 2, or is it less than 2, or does it include 2 or more? So here we have at least 2. So we have to make sure we are looking at the correct probability. So here we are looking at px greater or equals to 2 because we are using the word at least. Alright. Here, by right, you have to calculate px equals to 2 plus px equals to 3 plus up to px equals to 5. Why 5? We have n is equals to 5. That's the number of trials that you see here. So it's either you want to calculate one by one, which means that you have to calculate 1, 2, 3, and 4 values, or we know that this is actually the same as 1 minus with px less than 2. So when we do this, we try to see, is this a lesser, in terms of the calculation time, is this lesser, or is it actually worse than the first choice that we see here? So here, if we do px less than 2, we are actually looking at px equals to 0. Okay. And also minus with px equals to 1. That's it. You don't have to find what is px equals to 2 because 2 is not included. Okay, so your choice, either you want to use this way or you use this way. So this one, repetitive time is larger compared to this one. Okay, so try to solve this using the same formula. Okay, you should get about, so I leave it to you. So this is about 0 0.000, let me see how many zeros I have, 1, 2, 3, 4, 5, 2, 4, 9, 7. Okay, all right. Okay, so this is for question B. Okay, so for the third question, this is talking about, there's another part that I did not discuss, which is on range rule of thumb. Okay, so we have to look at the case of range rule of thumb. So in range rule of thumb, I think we've already looked into a little bit on the concept in the previous chapter. We are looking at what is the maximum value which is guarded by this formula, mu plus 2 sigma. And then we look at what is the minimum value. How to find this? We look at mu minus 2 sigma. So these are the two values that you have to calculate for the case of range rule of thumb. So you set this value, which means that you have to find what is mu. Okay. So mu for this case, it will be n times p, very easy to find. So n is 5, so p is 1 over 2000. So try to calculate this and then try to find what is your sigma. So sigma here will be square root of n p q. So we already know what is n, also we know what is p, what is q. So try to find this, plug it into this equation, and then try to set up your mean and also max. Then for this question, the third question, you try to decide whether 2, the value 2, is it a valid number or not in terms of this range. So if it is, then it means that it is not unusual. Okay? If it is not, then it is unusual. So you want to find whether this is unusual or unusual. Okay, so this is for the case of range rule of thumb. Okay, so I leave it to you to do for this range rule of thumb. Any questions, you can ask me. Okay, try to decide whether these two value, okay, the claim of 2 jackpots, getting 2 jackpots in 5 trials, is it actually unusual or is it usual? Okay, so I leave this to you to do. You can take a screenshot of this so that we can go to the next question. Probably I'll just briefly explain to you on the next question. Yeah. Okay, so this question 7, a little bit tricky. So here we have phone calls within 30 days. We have this person called Kiki. Within these 30 days, she made 47 cell phone calls, which were distributed as follows. No calls were made on 17 days, etc., etc., etc. So you see that these are not random calls, okay, because they are not distributed randomly, okay. They're not, because, yeah, this seems to be like a bit probably dependent in the case of maybe the number of calls are more because something happened on the day or etc. Okay, so but you see that there is not really distributed nicely within the 30 days. Okay, so let me ask you, what kind of distribution is this that you can see from here? Is this binomial or Poisson? Okay, someone said Poisson. Okay, so Poisson, why? Obvious reason. There is no number of trials given to you. There is no maximum number of, there is no winning, there is no success, there's no failure rate. Okay, so this is the point where you see that this is actually Poisson. Okay, right. So the first one, find the mean number of calls per day. Okay, so to find this mean, because you can actually see, from within these 30 days, there are 47 calls. So the mean for the Poisson can be defined by calculating 47 over 30. So this will be your mean. Okay, so this will be your mean. Then use Poisson distribution to find the probability of no calls on a day. Then compare the result to the actual relative frequency for the number of days with no calls. Okay, so for this part, it's quite easy to see that once you've already find what is your mu, then you are able to use your formula for Poisson, which you can actually find from your slides. Okay, so which means that you are supposed to find what is px equals to 0. Okay, use the formula, which is mu to the power of x e to the power of negative mu over x factorial. Okay, so this is the formula that you have to use. Try to see whether you can actually identify this value as 0.9810. All right, so for then you need to compare the result of the actual relative frequency for the number of days with no calls. Then you try to compare with this value, which is 17 over 30. Is this the same value or not? Okay, you can compare that on this particular value. Okay, if you have 0.9810 based on the Poisson, then you compare with this. No calls were made on 17 days. So 17 over 30, no calls, right? Then for C, this is talking about of one call on a day. So which means that you look at Px equals to 1. Okay, so try to calculate that using the Poisson distribution formula. Again, you try to compare it with the actual value that you see here, which is 7 days. Okay, 7 days, one call was made on each 7 days. So 7 over 30, is it the same or not with the value that you get here? All right. On the last part, based on the preceding results, does it appear that Kiki's cell phone calls made in a day for fit the Poisson distribution reasonably well? Okay, so for this case, look at the criteria for Poisson. Okay, so one of the criteria, if you look at in your slides, it has to be random and must be evenly distributed. This is the important criteria, these two. It has to be random, okay, and it has to be evenly distributed. This part, you look at as if it is random, but it is not evenly distributed. So therefore, it doesn't actually fit the Poisson very well because of these two criteria. So this is a bit about analysis, yeah. So a little bit on analysis on the Poisson distribution. All right. So I think I have about 3 minutes left. We might have another class after this. I don't know. But okay. So what I'm gonna do is that, can everyone switch on your video? I'm gonna take a quick, a quick photo on this. Hey, nobody wants to open your video? Alright, hold on now. Let me open up your QR code since you are here. If you are using your if you can use your phone to take the attendance, that'd be great. Okay, so I'm sharing the QR code. Great, that's fast. Anyone cannot fill up the QR code, you leave your metric number on the chat. Okay, that's great. So no one, I think only a few of you only turning your video. I don't know about the rest. I have a lot of students right now. So I just want to take photo of this. Maybe next time. So all right, so I think that's about it. For the next week, I will inform you when our next online discussion. If you have any questions, please just drop your question into the Telegram group chat. Alright, so please tune in to the channel for any news. So tomorrow, best of luck. Okay, best of luck on the mid-semester exam. Okay, so this is already 4 o'clock. You might have another class. I think I leave it to you to leave the meeting room because I need to key in the alright, welcome. I need to key in the QR. Alright, thanks everyone. Okay.